Hello and welcome to this Seaward Pat Refresher webinar series. This is session 3, types of equipment and their construction. My name's Kevin Smith, I'm Category Manager here at Seaward and I'm going to be taking you through this webinar series. If you'd like to connect with me about the content from the webinar or just any general inquiries for Seaward, I'm available via social media. So you can contact me via Facebook or you can connect with me on LinkedIn. So I look forward to hearing from you. So in this session, this is session number 3 of the Pat Refresher series. The Pat Refresher series is a series of 8 webinars designed to take you really from the start all the way through the subject of Pat testing over the 8 weeks. We're on session 3 now. The previous 2 sessions have been really well received. We're getting a lot of good feedback from people. So this session, we're going to actually start looking at the types of equipment that we might Pat test and how they're constructed. So the sections that we're going to look at specifically are the types of electrical equipment we may come across, how this equipment is constructed and the construction classes, and then how the equipment protects the user against electric shock. And once we've done that at the end, we'll have a live Q&A session. So if there's anything that we haven't covered, any questions that you've still got about the subject matter, obviously you can let us know your questions there and we'll answer those at the end. Or if you've got any other general wider Pat testing type questions, obviously feel free to ask those too. The way you ask the questions is to type those questions into the chat box and I'll pick those up either during the session or at the end. So with that said, let's get started. In this session we will learn about how electrical equipment and appliances are constructed. In addition to allowing the appliance to perform its intended function, its construction also protects us against electric shock. Often, in order to perform in-service inspection and testing on an item of equipment, we must first know how it is constructed and what measures the designer took to provide electric shock protection to the user. Once we know what protective measures are employed within the appliance, we will then know what items to inspect and what items to test. Identifying the protective measures within each different item of equipment encountered is one of the most difficult tasks faced by portable appliance testers. And in this regard, there is no substitute for experience. Identifying types of electrical equipment. Although the law makes no distinction, the IET Code of Practice separates electrical equipment into types. The types of equipment approximately relate to the risk posed and therefore impact on the frequency of tests and in some cases the pass-fail limits. It is a common mistake to assume that PAT testing only applies to portable equipment. In actual fact, portable is just one of the types described in the IET Code of Practice. Below is a list of equipment types referred to in the IET Code of Practice. So the first one we've got here is portable. We talk about PAT testing, portable equipment, and portable equipment is defined as anything less than 18 kilograms in mass that's designed to be moved from one place to another. So generally they talk about this 18 kilograms limit. That's not in the law, that's not there, it's just part of this definition of what a portable piece of equipment is. So a lot of things we think of portable, we could think of something like a kettle, for example, as a typical piece of portable equipment. Movable equipment. This is equipment that's very similar to portable, and it's either something that's 18 kilograms or less in mass and easy to move around, maybe like a heater or something like that, maybe, that you wouldn't say was portable, but it is movable. Or it's something that's actually got wheels or casters or something like that to facilitate movement, so maybe like a compressor or a welder. You wouldn't really call it portable. It's not under 18 kilos, but it's designed to be moved around. Now the thing with portable and movable equipment, they are considered to be relatively high risk because of the chances are people are moving them around. That may lead to more damage. Also, people are likely to be in contact with them when they are moving them around. So generally, portable and movable equipment are tested quite often because they are seen as being slightly higher risk for that reason. Now, one that is seen as high risk, and typical example here on the slide you can see the hand drill, is handheld equipment. And the reason handheld equipment, I mean, handheld equipment is really what you'd class as portable equipment, but handheld equipment is equipment that's designed to be held in your hand during normal use. Now, the problem with this is, where's it going to be when it goes wrong? In your hand. So the likelihood of somebody getting an electric shock if this piece of equipment goes wrong is a lot higher. Therefore, handheld equipment is generally seen as being higher risk. Stationary equipment. Stationary equipment is things like your fridges, your freezers, your washing machines, your vending machines, all that sort of stuff. Really big chunky bits of equipment. They're not really moved around a lot. So they're seen as being slightly lower risk items, obviously depending on what they are, but generally they're seen as being lower risk because the cable isn't constantly being moved about. It's not likely to be a trip hazard. It's not likely to be sort of unplugged and plugged in a lot of times. Generally, stationary equipment is put in place, connected to the supply, and then left alone. The chances of you being in contact with it when it goes wrong are a lot lower than, for example, portable or certainly handheld equipment. Fixed equipment. Now, fixed equipment is generally equipment that's intended to be fixed in a set location. So this could be something like a hand dryer, this could be something like a water boiler, this could be a electric radiator or something like that, fixed equipment. Now, the name has sort of got taken really to mean equipment that's permanently connected to the fixed installation. Now, that can be taken as true. We've talked before in previous sessions that it doesn't really matter whether these equipments are connected via means of a plug or socket or whether they are connected directly to the fixed installation. These categories still apply. Fixed equipment is generally something that's fixed in a set position, i.e. screwed to the wall or screwed to the floor from that side of things. So maybe on a plug and socket, maybe hardwired, but fixed equipment is something that's fixed in a permanent position. Generally, again, depending on what it is, generally seen to be slightly lower risk because the less likelihood of it being picked up, put down, dropped, moved around, those sort of things, or that you're likely to be in contact with it when it goes wrong. But it is still very much a part of portable appliance testing. Built-in equipment. Now, built-in equipment really refers to things, maybe kitchen units where you've got a built-in cooker or built-in fridge, something like that. So very similar to stationary equipment. The problem with built-in equipment, sometimes it can be quite hard to get access to it to carry out proper visual inspections and access things like the cable to carry out tests and stuff. So built-in equipment is another category of equipment. IT equipment. Now, generally when people see IT equipment, they think of, monitors, PCs, printers, maybe things like that. I tend to use the term electronic equipment, anything that's got electronic circuits, electronic components in there. Now, again, this generally tends to be pretty low risk equipment, due to what's going on with it and the likelihood of it actually causing injury to somebody. However, it can be quite sensitive. So IT equipment, electronic equipment, we do need to be careful when we're actually applying tests to make sure that we don't damage this type of equipment. Now, there's also some other sort of what I've called subtypes that are mentioned in the IT Code of Practice too. So things like leads and extension leads. So it could be kettle leads, could be extension leads, multi-way adapters, RCD adapters, and surge protected devices. All of these things are mentioned in the Code of Practice and probably are actually normally seen as portable. So they normally fit into the portable category, but obviously they are sort of mentioned in separate sections in their own right. So the thing to be aware of is we've got all of these different types of equipment, and all of the equipment types that we come across, basically they all need testing, they all need inspection, they all need testing. They are all electrical systems, just like we looked at in previous sessions. The electricity work regulations just says we have to test electrical systems, and that's everything from a pocket calculator to a power station falls under those legislation. The IT Code of Practice breaks it down into portable, movable, handheld, stationary, just to make things easier for people so you can put it in context and you can understand a little bit more about the risks and how these things group together. Now, due to the wide variety of equipment that may be encountered on a day-to-day basis, it's easy to see that not every piece of equipment will fit easily into a single type or definition. And disagreements over an equipment's type are to be expected. So, for example, I've got a kettle there. Is that portable? Is it handheld? Could you argue that it's actually movable? And again, really, does it matter? Because at the end of the day, a kettle is a kettle. From a regulations point of view, it's electrical equipment. If it's used in the workplace, it falls under the Electricity at Work regulations, and we still need to test it. So really, whether it's portable or handheld or movable doesn't really impact things very much, and you could make a case for it fitting into all of those categories. So from that side of things, it is expected. There is no definitive answer. So as the law simply refers to electrical systems and not equipment types, the allocation of types is not black and white. It's not a black and white process, and should be made using the competent person's knowledge and experience on a best fit basis. Which category does it fit into best? So from that side of things, don't get too hung up on actually working out exactly, well, this has got to be, I've got to know exactly what category it's in. Look at the risk, use your knowledge, use your experience, you're a competent person, and really work out which category does it fit into best. Now, bit of a curveball here after I've talked about all of those things. In the new 5th edition Code of Practice, we're actually getting rid of all of these different categories because, again, they're not borne out by the law. They're not actually mentioned in the law, and also it does cause confusion. So, in the new 5th edition Code of Practice, which is coming out later on this year, probably September this year, we will see all of the categories being removed, and we'll just refer to everything as electrical equipment. So that makes things a lot simpler. It makes things a lot easier. We haven't got to try and work out what category something fits into for how often it gets tested or what the pass-fail limits are. We just simply say, this is electrical equipment, we need to deal with it, and then we use our knowledge and experience to do that. So watch out for that. Later in the year, things are going to get a lot simpler. So now we're going to take a look at equipment construction classes. You may well have heard of people talking about Class 1 and Class 2 equipment. In this case, now we're going to take a deep dive into it and give you the background on what that actually means. So in addition to identifying equipment by type, we also identify equipment by its class of construction. In very simple terms, there are 5 different classes of equipment, ranging from Class 0 to Class 3. So basically, the higher the class number, the lower the risk it poses to the user. When a designer designs a new appliance, they must consider how the user is to be protected against electric shock. There are many ways in which this can be achieved, so to make things simpler, the designer will choose one of 5 standard methods or classes. Nowadays, almost all equipment you come across will be either Class 1 or Class 2. However, to the right is an example of Class 0 equipment. This equipment has no basic insulation around the live conductors. There is no supplementary insulation or earthing of exposed parts. In most cases, Class 0 equipment should fail visual inspection and be removed from service. The same is true for Class 01 equipment, which is similar to Class 0 but has an earth terminal. So you can see here this typical example of Class 0 equipment. We've got a picture there of these old Christmas tree lights, and you can see that we've got the live conductors inside the cables, and we've just got this sort of transparent green insulation on the outside of that. There's no sheath for providing the mechanical protection. There's no earthing of any exposed parts. There's no double insulation in there. All we've got is 230 volts separated from us by that green transparent insulation. So you can imagine if we had a nick in that green transparent insulation, straight away we could touch live parts and there wouldn't really be anything there to protect us in the case of that. So again, nowadays generally seen as dangerous equipment, and usually failed straight away on site and removed from service. Similar with Class 01 equipment. Class 01 is Class 0 equipment, but it does have an earth terminal. So sometimes you imagine an old brass lamp or something like that with a 2-core flex going to it, but there's an earth terminal. So if somebody wanted to, they could connect an earth wire to the metal parts, but that's not earthing as part of the plug. That's just somebody could put an earth to it if they wanted to. So generally, in most normal environments, Class 0 or Class 01 equipment is failed on site. It is allowed in very specific sort of testing environments, maybe where you've got an insulated environment or something like that, a rubber room, for example. But for normal part testing, normal place of work, if we see class 0 equipment or class 01 equipment, generally that's failed on site. So we only mention it in here really. It is very rare, but you may come across the odd piece of older equipment and wonder what's going on with that. But as I've said there in the slides, most of the equipment you'll come across will either be class 1 or class 2. So this is a typical item of class 1 equipment. So the user is separated from live parts by basic insulation. You can see the grey basic insulation there. And exposed metal parts that could become live if the basic insulation should fail are connected to earth. So you can see there we've got our earthed metal parts. So if there's a problem with the basic insulation and the live parts came in contact with exposed metal parts, so exposed metal parts that could become live if there was a fault, then in that case those parts are connected to earth. So you can see what we've got is really a two-stage process. We've got the basic insulation providing the basic protection. That's what's protecting us all day, every day under normal conditions from the things that are meant to be live. If there's a fault with the basic insulation, then we've got earthed metal parts. We earth the metal parts, and that provides the fault protection. So if the metal parts were to become live, straight away that fault current would be diverted down to earth, and that would operate our fault protection within the main electrical installation. So your circuit breaker would chip, your fuse would blow, your RCD would trip from that side of things. Now, class 1, this is a protective measure that we refer to as ADS, automatic disconnection of supply. And the reason for that, that's the protective measure used in most electrical installations in the UK. And what that means is that if there is a fault, like we say, your protected devices operate and you get that automatic disconnection of supply. The supply is switched off by the circuit breaker, the fuse blowing, or the RCD operating. So in most protective measures, ADS being one of these, you will see this double layering of insulation. Double layering of protection. We've got the basic insulation providing the basic protection, then we've got earth metal work and the earthing, the ADS, as the fault protection. So we've got both basic and fault protection. Whereas in something like class 0, remember from the previous slide, we only had basic insulation. There was no additional layer of protection there. There was no fault protection. So if something had gone wrong with the basic insulation, you're on your own. It's tough luck really from that side of things. So this is where class 1 comes in. So normally you'll see class 1 equipment is equipment that's got a significant amount of metal work on it. It's got a metal case. And therefore that metal work, the way we're protected from that is by connecting that to earth. Now, there is a bit of a curveball. You can get unearthed metal work on equipment. Sometimes you might get the odd handle or the odd plate or bits of metal work where you think it should be earthed and actually it isn't. And the reason it isn't is because the designer has decided that there's no way for it to become live under fault conditions. So potentially there's insulation between it, there's earth metal work there already. So a typical example of this might be an office fan. The metal guard around the fan blades is metal. It's exposed so you could touch it, but it can't become live under fault conditions because the live parts are in the motor. If the insulation within the motor was to fail, the body of the motor is earthed. So that will automatically trip off and automatically protect the user. So the blades of the fan around the outside are really just there to stop you poking your finger in. They're not there to actually provide electric shock protection. They're not going to become live in the case of a fault. So it is acceptable to have unearthed metalwork on class 1 equipment. And one mistake people make when they're new to part testing is they automatically assume that every piece of metal on every equipment must be connected to earth. And a lot of people will fail something like an office fan. They'll do an earth continuity test on the guard around the blades, and they'll say there's no earth there, that's not earthed, it's faulty, chuck it in the bin. Whereas actually if you test on the motor that's meant to be earthed, perfect, got a perfect earth connection, so the actual shock protection, the ADS, is there, it's all working, we've got basic insulation, we've got our earth metal parts, and we've just got unearthed metal work in part of that process. And if we test unearthed metal work and it fails an earth continuity test, don't be surprised. And that's one of the hardest things we as pat testers have to deal with is making the decision, is that earthed metalwork, is it unearthed metalwork, did the designer intend it to be earthed? And generally it is quite hard sometimes to actually make that evaluation. And obviously sometimes the only way you can work that out is to actually speak to the manufacturer, or maybe dismantle the equipment to a certain level, but we try and avoid that where possible, to actually determine, or maybe even do some continuity testing to try and test out which bits of the equipment are designed to be earthed for safety purposes and which bits are unearthed metalwork. But don't assume that on every piece of equipment everything should be earthed. Now, how do we identify a piece of Class 1 equipment? Because again, this is one of the hardest bits, is actually identifying equipment. So, where it's possible to remove the plug top, obviously we do have moulded plugs now a lot of the case, but where it is possible to remove the plug top, we will observe 3 wires connected inside the plug. So obviously, you take the plug top off, you have a look inside there. We're going to do that for visual inspection anyway to make sure that the thing's correctly wired. But if you look in there and there's actually an earth wire connected to the earth pin, that's generally a very good indication that that is going to be Class 1 equipment. It's not 100%. Sometimes Class 2 equipment does have an earth for functional screening purposes. Maybe anti-static dissipation is quite common on vacuum cleaners and things, where they actually have an earth there to stop static build-up, and that's not there for fault protection. But generally, in most cases, if you can take the plug top off and you look in there and you see there's an earth wire in there, 99 times out of 100, that means that's going to be Class 1 equipment. The presence of the earth wire is a strong indication that it's Class 1 equipment, as I said. The plug of Class 1 appliances will always have a metal earth pin, and this can aid identification. So if you see on the plug from the outside, you see that we've got a plastic earth pin, that's generally telling you they're not expecting any continuity through that. It's just there to actually operate the shutters on the socket when you put the pins in and things like that. So yeah, so if it's Class 1 equipment, there will be a solid earth pin. One thing to watch out for on counterfeit equipment, sometimes you will come across half-sleeved earth pins. So you've got an earth pin that's half metal and half plastic. That's totally dodgy, it's totally counterfeit, so if you do see those, please fail them straight away. They shouldn't be like that. They should either be entirely insulated if it's Class 2, so you just got a plastic pin, or it'll actually be a brass pin. Class 2 equipment can actually have a metal pin as well, so it's not an indication that just because there is a brass pin there that it's definitely Class 1, but obviously Class 1 equipment will always have a conductive pin, so that's another thing you can do to say, I'm on the right track, I'm starting to identify these things correctly now. So it's often possible to read the information printed on the side of the mains flex. We talked about this last time. On the side of the mains flex, you can actually see the size of the cable printed on there, but you can also see the number of cores. And in this case, on this diagram, you can see it says 3G, which means 3 core. So even if this was a molded plug, if we looked on the side and it said there was 3 cores in there, that's always going to be generally line, neutral and earth. So because it's going to be, if it's 3 core, it's line, neutral and earth, you know there's an earth in there. That again should be telling you pretty much, definitely that it's going to be a Class 1 appliance. Now, a successful earth continuity test gives us the final confirmation that the appliance is actually Class 1. So generally you'll assume it's Class 1, you'll go ahead and do a Class 1 test, you'll do an earth continuity test to earth metal parts, and obviously if it passes, then you say, yeah, I'm pretty convinced Class 2 equipment won't have any earthing connection through to metal parts. So if you've done your Class 1 test, you're getting earth continuity there, you're pretty convinced there that you've actually identified that equipment correctly. Great care must always be taken when identifying the class of equipment, and you must always consider the possibility that the equipment may have been subject to poor quality DIY repairs in the past, where, for example, the plug or flex may have been changed and replaced with non-original parts. Yeah, so be very careful with that. Somebody could have come along and they've actually, I've seen this in real life where somebody's come along and they've only got 2 core flex and they've just used 2 core flex instead. So you look at it, say, oh yeah, it's Class 2, and actually it isn't Class 2. It's just been, basically, it's been bodged in the past, and you're coming along and you're assuming, yeah, oh yeah, it's right. So always be on your guard a little bit, just be aware, is this original? Has somebody come along and changed the whole flex on here? and just left the earth out. I've also seen appliances where they've used 3-core cable, but they've actually cut the earth off because it was tripping. So it's causing problems, it's tripping the RCD because the equipment's faulty. Oh, that's a nuisance. Let's cut the earth off to stop it tripping. And you might look at it and go, oh, actually, yeah, it's class 2 equipment, that's fine. Not check the earth and not actually carry out the correct insulation resistance test, and you end up passing equipment that's actually faulty. So always be aware when you're identifying equipment. Don't always take everything at sort of first value. Look at it again at first sight. Look at these things again and just make sure that it is as the manufacturer intended. And this is always a good argument for why we test new equipment when it enters the workplace, and why we keep a history. So if we've tested equipment when it's entered the workplace, we know it's in original condition, we can record that down, and then if there's any arguments later on, we can look back at the records and say, well, when it was new, it was class 1, therefore chances are it should be class 1 all the way through its life. So it is important with that to just be aware and make sure that you don't always take things, at a rush, and don't always take things just on first sight, that you do dig a little bit deeper and do a bit of detective work to make sure you haven't been hoodwinked. Where any doubt exists, the advice of the manufacturer should be sought. Yeah, if you don't know, that's okay. It's okay if you don't know. If you don't know how to test something, you don't know how to do it. The worst thing you can do is not know and do it anyway. So if ever you come across a piece of equipment, you're not sure what's going on, take a step back, say, I can't test it, I need to do some more research, I need to ask somebody, I need to check with an electrician, I need to check with the manufacturer. Absolutely fine. Worst thing you can do, as I say, is dive in, not sure, do it anyway, and that's how accidents happen. So if in doubt, always check. So class 2 equipment. So what we've got here is a typical item or a diagram of a typical item of class 2 equipment. So a class 2 drill, for example. So the user separated from the live parts by basic insulation and supplementary insulation. So what you can see here is we've got unearthed metal parts. So we've actually got a metal drill chuck. So the chuck of the class 2 drill is metal, but it's not earthed. It doesn't need to be earthed because it's separated from the live parts by 2 layers of insulation. So we've got the grey basic insulation, and then if something goes wrong with that, we've got the second layer of supplementary insulation. So our basic insulation provides the basic protection. The supplementary insulation provides the fault protection. So instead of on class 1 equipment, our fault protection was provided by earthing metal parts. In this case, we don't earth the metal parts, we just use more insulation. So if anything goes wrong with the basic insulation, we've got even more insulation there. This is often referred to as double insulation. You might hear people talk about double insulated equipment, the protective measure, double insulation, double or reinforced insulation. And it's just a different strategy for doing it. Quite often this is seen, as I mentioned earlier, seen as being safer. And the reason it's seen as being safer than class 1 equipment is because it doesn't rely on the earth for its safety. So with class 1 equipment, if that earth goes, you've lost that earth contact. If that earth connection hasn't been made, or it gets dirty, or there's a bad connection, you've lost your fault protection. Whereas it's very hard to lose a second layer of insulation. So almost with class 2 equipment, the safety is built in. You're not relying on the resistance of the earth connection. And also, if you've got quite long leads and things like that, obviously we talked last week about the longer the cable is, the higher its resistance is. It's exactly the same with earth wire. So if you've got a long extension lead, the resistance of that earth is getting longer and longer and longer, and as a protective measure, it's getting less and less effective. The disconnection time is getting longer. So in this case, by having the 2 layers of insulation built in, we're not reliant on the resistance of that earth path. We're also not reliant on the safety of the earth in the fixed installation. So sometimes you might be doing work in properties where you think, actually, has this installation ever been tested? How do I know the earth in the installation's okay? My appliance might be fine, but do I know the installation's safe? Whereas with double insulated equipment, the protection is built in, the fault protection is built into the equipment. So it's safer. Normally class 2 equipment tends to be equipment that's got more of a plasticky construction. Now, it is still possible to get metal cased class 2 equipment. So class 2 equipment may have metal parts. It may have a full metal case. You think of something like maybe a DVD player or something like that. It might have a metal box around it, but generally it's got a figure of 8 lead. It's a class 2 appliance, and there's 2 layers of insulation in there, the double insulation inside the appliance. If we put a metal box around the outside of that, it doesn't matter. It doesn't need to be earthed because it's not going to become live under fault conditions. So don't automatically assume that class 1 equipment is shiny metal and class 2 equipment must be a big blob of plastic. It isn't necessarily that clear. The difference is how are we protected from the live parts? How has the designer done that? And sometimes, again, it can be quite difficult to actually identify what's been done. So one layer of reinforced insulation can also be used in class 2 equipment, yeah. So we think of double insulated equipment as having 2 layers of insulation. One that provides the basic protection and another one that provides the supplementary insulation. We can use this super stuff called reinforced insulation, and effectively that's a super insulator, a really tough piece of plastic that actually has equivalent resistance and strength to 2 layers of normal insulation. So many times if you actually take a drill apart, you'll just see it's one moulding, but that'll be one moulding of reinforced insulation between you and the live parts rather than 2 physical layers. It's a bit hard to get your head around, but it does provide the same level of insulation protection between the two. So how do we identify class 2 equipment? The identification of class 2 equipment is usually by the presence of double insulation construction mark. So you'll see on the right hand side there we've got the double insulation construction mark, that box inside a box, and underneath the mark you'll actually see an example there of a rating plate from a stereo turntable system, and you'll see displayed on the rating plate there we've got that double insulation mark. The IET Code of Practice advises that where the mark is not present, the equipment must be treated as class 1. So what they're saying is if you can't identify whether it's class 1 or class 2, always treat it as class 1. Now obviously if you treat it as class 1 and it is class 2 equipment, it's going to fail the earth continuity test. But what they're saying is it's better that it fails and then maybe you go back, speak to the manufacturer, do some more investigation, than just assuming it's class 2 when actually it might be class 1 with dodgy earth. So they're saying to be on the safe side, if you can't identify it, treat it as if it's class 1, and obviously if it passes the class 1 test, then you know it was actually class 1. Now the class 2 construction mark should be on all class 2 equipment, so generally that's the definitive guide. If you don't see the mark, it's not class 2. If you see the mark, it's class 2. So generally that's the easy way of doing it. Now sometimes the mark might have got scratched off, it might not be apparent, so you might need to do a bit more investigation. So what do we do in that case? Well again, going back to the logic we use with class 1 equipment, other additional methods to aid in the identification of class 1 or class 2 equipment include the absence of a protective conductor inside the plug. So if it's not a moulded plug and you can take the plug off, you look inside there and you can see there's no earth, there's no protective conductor. So generally you're thinking, well, that aligns with what I know about class 2 equipment. There's no earth and there isn't an earth in there. A 2-core flexible cable. So again, looking at the diagram there of the side of the cable, we can see printed on the side of the cable it says 2 times 0.75. So that's telling us it's a 2-core cable. So even if it's a moulded type plug, we could still look at it, and if it says it's a 2-core cable, as long as that's original cable, you would assume excuse me, you would assume that means it's class 2. It's got the line and the neutral in there and no protective conductor, no earth. Plastic earth pin. Again, I did mention that if you do see a plastic earth pin, generally that means that it is class 2 equipment, because class 1 equipment will always have a metal or a conductive earth pin. It won't have a plastic earth pin. So again, where any doubt exists, the advice of the manufacturer should be sought. So always err on the side of caution. If you don't know, always check with somebody who does from that side of things. It's never a problem to stop testing and say, look, I don't know, I need to do some more investigation. So the final one, and again quite rare in this case, is class 3 equipment. So where increased levels of protection against electric shock are required, for example in bathrooms or outdoors, it's often necessary to use class 3 equipment. Class 3 equipment is specifically designed with safety in mind and offers levels of protection above and beyond that of Class 1 or Class 2. Class 3 equipment is supplied from a separated extra low voltage source. So generally these will be powered from a separate transformer, which will be a source of separated extra low voltage. Separated extra low voltage sources provide a separated supply. Now what that means is that they're not actually connected to the incoming supply. There's actually electrical separation. There's usually a transformer between the two. A bit like you might see a shaver socket sometimes in a bathroom and things like that. The secondary windings are not connected to the incoming windings. So if there is to be say you get an earth fault, you're in contact with earth and you touch either the line or the neutral, there's no flow of current. There's no way the current can flow to earth because the system is separated from earth. In a normal installation, normal electrical installation, the neutral is always connected to earth. So that's how the system works, but it also means that you can then, if you're touching earth and you touch a live conductor, you can get a shock. Whereas with separated systems, that just can't happen because they are electrically separated. Now also the ELV part of that, the extra low voltage part of that, means that the supply will not exceed 50 volts AC or 120 volts DC. And this adds to the user's safety. So not only have we got the protection usually in there, similar protection to Class 2, we also add that extra level that it's separated, so we can't get any shocks to earth, and also that the voltage is reduced to safe levels as well. So by the time you add all that up, that's why SELV systems or Class 3 systems are used in things like bathrooms, used outside in gardens, maybe the Christmas lights, things like that you might come across are Class 3. Quite often people get confused with things like phone chargers and stuff like that and say, oh yeah, phone charger, that's Class 3. No, it isn't. There's several reasons for that. The main reason being it's connected to the mains. So because it's connected to the mains, the highest voltage presence inside there is 230 volts, in which case it's not SELV, so it can't be Class 3 anyway. But generally most of those things like phone chargers are going to be Class 2. And you'll see the Class 2 construction mark on there. Only if you see the Class 3 construction mark, or it's marked up with something like SELV, or there's various British standards that these apply to, would it fit into that category. But SELV equipment, Class 3 equipment, is very, very rare, and it's only generally used in sort of those super safe applications. So always, when you look at something, generally it's going to be Class 1 or Class 2. Class 3 is very rare, and you are very limited on the tests you can carry out on Class 3 as well. There's not a lot you can do other than a very good visual inspection really there, because the level of protection means there's not a lot there for us to test. There's no earth, for example, and that sort of thing. So Class 3 is quite rare. So with the construction classes, generally the ones you need to swat up on, Class 1, Class 2. Obviously we'll look later in this series at how we test those appliances, but by identifying whether it is Class 1 or Class 2, or maybe one of the others, then you know what do I need to inspect and what test do I need to carry out, and that's the important part of it. So the final section we're going to look at is protection against electric shock. How are we going to bring all these things together to actually understand how the equipment, how the design of the equipment protects us against electric shock? There's two types of electric shock that equipment must protect the user against. Direct contact. Direct contact is touching a part which is intended to be live. So this is something that's meant to be live. In every equipment, there will be parts that are designed to be live. For example, the conductors inside the cable are meant to be live. If we come into contact with those and get an electric shock, that is what we call a shock by direct contact. We're protected from direct contact by our basic protection. Usually this is in the form of insulation or the enclosure. So on the right, the element of the toaster is a live part, which is intended to be live. We want it to be live, so it'll toast our toast. The toaster's enclosure provides the basic protection. So there, if I'm daft enough to stick a fork in and actually contact the live parts, that is the enclosure, that's the basic protection that's failed, and that's me coming into direct contact with a part that is intended to be live. So the way we protect against that is by providing basic protection. Basic protection is there to protect you all day, every day against the things that are intended to be live. It's effectively our first line of defense. Now, indirect contact is touching a part which is made live only by a fault. So these are things that shouldn't be live normally, but could become live if there was a fault. So we're protected from indirect contact by fault protection, such as the earthing of metal parts in Class 1 equipment or supplementary insulation in Class 2 equipment. On the right, the neck of the lamp can only become live due to a failure of basic protection. So if the basic insulation, you imagine in the neck of that light, there's two cables going up inside there, the line and neutral, they've got insulation. Now, if over time they get shorted out, they get frayed, the basic insulation around them has failed, in which case the body of the lamp has become live. Now, what's going to protect me? If it's Class 1, that neck of the lamp will be earthed. So we get automatic disconnection of supply. The supply trips off and protects me, so that either when I come to touch it, straight away it's tripped off, or it's already tripped off before I come to touch it, so I can't get a shock. If it's double insulation, we'd have 2 layers of insulation in there. So if it's Class 2, we'd have basic insulation and we'd have even more insulation. So the chances of those 2 layers failing in one go are pretty, almost non-existent. So indirect contact, touching something that's meant to be live, something that's not meant to be live but has become live due to a fault, is indirect contact, and we have our fault protection which protects us from that. Now, what I've done, I've pulled all these things together into a nice handy chart that we can talk through so we can understand how basic protection and fault protection works to create a thing called a protective measure, and how that's employed in all of the various classes of equipment that we come across. So if we start off with Class 0, as we said, Class 0 is quite old-fashioned now and sort of something we would probably fail on site. So in this case, Class 0, the protective measure, there's only insulation. That's all we've got. And we've got basic protection provided by basic insulation. So you remember those Christmas tree lights, we've got the basic insulation, that transparent green insulation around the wire. And fault protection, nothing. So if that fails, we've got no fault protection. So in that case, that's why that's seen as dangerous nowadays. It's not seen as being good enough. We always need to have a combination of basic protection and fault protection. So Class 1 equipment, this is the protective measure ADS, automatic disconnection of supply. And the basic protection is provided by basic insulation. If the basic insulation fails, we have protective earthing. Anything that's conductive, that could become live if the basic insulation was to fail, will then be connected to earth. We get automatic disconnection of supply, the current flows to earth, operates the protected devices, disconnects the supply, ADS. Now, for Class 2 equipment, we use double or reinforced insulation. So the normal double insulation, we've got basic protection provided by basic insulation, and the fault protection is provided by supplementary insulation. We've got even more insulation protecting us from the live part. So even if the basic insulation were to fail, we've still got more insulation before we could come into contact with the live parts. We could do the same, as we mentioned before, with a single layer of reinforced insulation, as long as it's got the same properties of 2 layers of basic and supplementary insulation. And then the final one, Class 3, that we talked about, that utilises the protective measure of SELV, SELV, separated extra low voltage. The basic protection, again, generally is still basic insulation, but the fault protection is provided by SELV. So in the case of SELV, we're separated from earth, so we can't get any faults to earth at all. There's just no circuit there, so it's impossible to get electric shock between earth and any of the live conductors. And if we do touch the live conductors directly between the 2 live conductors, it was going to be an ELV, an extra low voltage, so it's going to be a safe level of voltage anyway. So that's what makes Class 3 or SELV systems sort of super safe. And they're the ones I say we use in sort of environments where there's increased risk. So that gives you a good breakdown of how the protective measures are distributed across the various classes and how the basic protection and the fault protection is carried out. Now obviously this stands us in good stead for when we go on to do the inspection and testing, because we know what have we got to inspect, what have we got to test. We've got to check that the insulation does what it's meant to do, the basic protection, and in the case of class 1 equipment, that the protective earthing is doing its job as well. So having a good understanding of the protective measures gives us a very good understanding for the tests that we need to carry out later on in this series. So in conclusion, we said we were going to look at the types of equipment and their construction. So we looked at the types of electrical equipment. We went through movable, portable, stationary, handheld, all those sort of things, and we understood how they all fit together. The equipment construction classes, we looked at each of the equipment construction classes, and we now understand how they provide basic protection and how they provide fault protection, and how to identify those classes. And we summed up at the end with how that protects the user against electric shock, how we use that to create the protective measures, and how that provides electric shock protection. So moving on to next week, session 4, we're actually going to get on to doing a bit of visual inspection. We're going to look at the user checks, so the checks that a user carries out when they're checking a piece of equipment, maybe doing a daily or weekly user check, and then we're going to look at the formal visual inspection, so how somebody, a competent person who's actually carrying out PAT testing, would start off and carry out a visual inspection, what we're going to be looking for and what items we need to check there when we're carrying out a visual inspection on equipment. So at this point, generally, we thank everybody for your time. So thanks very much for watching this webinar, and we'll open this up to your questions. So if you haven't done so already, please type your questions into the chat box and we'll go through those. So thanks for watching so far, and it's over to you.